Okay, so we're going to work another problem together. Once again, solving the triangle. We want to solve triangle ABC. I've drawn it for you here, but notice that the information that we are given on this triangle has all three sides already given. So I'm supposed to find then the three angles that are on the inside. Now I can't use the law of sines right now because I don't have an angle side pairing. So what I'm forced to do then is to utilize the law of cosines to come up with a missing angle. There is a pattern, or there is a process that we want to go through when we are choosing which of those three angles do I want to choose, and it has to do with I want to apply the law of cosines to the largest angle in the triangle. So we're going to start with the law of cosines on the largest angle. Now remember that the largest angle is going to fall across from the largest side. So that would be side C. And so that tells me that I'm going to be solving using the law of cosines to find angle C. So let's write the formula, which would be c squared equals a squared plus b squared minus 2ab times the cosine of angle C. And there's two ways for you to think about this. One way would be to plug all of the numbers, all of the sides in in my formula and solve for angle C, or I could rearrange the formula solving it for side C and then plug the numbers in. And I think what I'm going to do for you right now is I'm going to show you how we rearrange this formula so that you can see mathematically what we're doing as we are solving for angle C. So angle C, I'm going to highlight it over here. This is what I want to get all by itself. Now whether you plug the numbers into this or not, this is usually the step where students miss this process the most in class. And in order to get cosine C, or C, angle C all by itself, I'm trying to isolate it. So to isolate my variable here, I want to look in the equation and see what's going on. Notice that a plus b minus 2 times a times b times cosine C. Okay, I said all of that to you so that maybe you would hear me saying that this portion here that I'm highlighting in blue is being multiplied by C, but this portion over here is being added to portion C. So in order to solve this algebraically, we usually subtract things that are being added, right? So I am going to subtract a squared plus b squared to the left-hand side. So that gives me c squared minus a squared minus b squared, still equal to negative 2 times a times b times the cosine of C. Now once again, I'm trying to get angle C by itself, so we would divide by the negative 2ab, because those are the things that are multiplying times cosine of C. So let's divide both sides by negative 2ab, and what we end up with is this left-hand side of c squared minus a squared minus b squared, all equal to negative 2ab, and that's, or divided by negative 2ab, and that's equal to the cosine of angle C. So we would come through at that point, we would take the inverse cosine of both sides, and that's going to give us our angle C. So I'm going to put these things into my calculator, and knowing how the formula has actually been rearranged for me, c squared minus a squared minus b squared divided by negative 2ab, and I'm going to round that then to, let's round it to the nearest tenth. So I went ahead and I wrote down what it was that I was about to put in my calculator. That would be this step right here that you see. I just replaced the letters with the actual values that we were given in the problem. And you know, we all work our calculators a little bit differently, so moving however you go through the process of simplifying that and figuring out what your angle is on your own calculator in as many steps as you need to understand what you're doing is fine. That works for me. As long as you can come up with the fact that angle C ends up being 118.6 degrees. So with this particular problem, solving this equation, using the law of cosines and solving it, so to speak, for the angle that was inside of the formula was a little bit different from the process we used before. Now over here on this side, I did kind of allude to the fact on which step my students tend to miss the most. I'm going to come back to it just one more time. So when my students, whether you rearrange the formula first or whether you plug the numbers in first, more often than not, almost 80% of the students do the wrong step right there in that piece that I just highlighted. So most of the time when we just have the numbers written in that step, students will they'll inadvertently or not realize that they go ahead and they take a squared, they'll add that to b squared, then they'll subtract 2 times a times b all in one step, and then divide both sides by that value that they get. And I'm hoping that you're looking at that going, wait a minute, that doesn't even make sense. That's not right algebraically. We would never do that, which that's right, we don't do that. But it's hard to see when you have the actual numbers in there. And I would encourage you, if you get confused or if you're not sure whether or not a process is I guess legal algebraically, let's break it down into something that might be a little bit easier to recognize. Here I just have a simple linear equation, 4 equals 3 minus 2x. And if you were thinking about solving that equation, you would never think that you could take 3 minus 2 first, right? You would always move the 3 to the left-hand side or subtract 3 to the left-hand side and then divide both sides in the next step. So if you break it down into something that is more recognizable, that you are familiar with, it tends to help us with our algebra. So I just wanted to highlight that point because I know most of you would probably not go through the process of rearranging that formula. And if you don't, that's perfectly fine. You're not wrong at all. If you wanted to just stick all of the values for the sides C, A, and B into the existing formula and rearrange it from there, go for it. There's nothing wrong with that. But I'm just warning you that of the error that most of my students typically make. So just watch out for that. So now that we have found angle C, we have 2 more angles that we want to solve for. So the second step in this process is to go ahead and so I'm going to use the law of sines on either of my 2 acute angles. So either of the remaining angles. So we started out using the law of cosines. Now we're going to use the law of sines. So what do I have here? I solved that for angle C. So my known ratio has to be little c over the sine of angle C. And that's equal to, let's just pick angle A. Angle A, or side A, divided by the sine of angle A. So filling in some values here, we have side C, which is 59.3, divided by the sine of angle C, which was 118.6. That's equal to side A, which is 25.4, divided by sine of A. So doing a little algebra, cross multiplying here, I get 59.3 times the sine of A equals 25.4 times the sine of 118.6. Divide both sides by 59.3, giving me the sine of A is equal to that fraction of 25.4, or yeah, times the sine of 118.6 divided by 59.3. And then when we solve for the angle, remember we're going to take the inverse sine, put that whole thing into your calculator, and you should find out that A rounded to the nearest decimal place would be 22.1 degrees. So now I have angle A and angle C. I can use on the last step. The easiest part is to just use what we know about the sum of the interior angles of a triangle. So angle B would be 180 degrees minus angle C of 118.6 minus angle A of 22.1, giving me a grand total for angle B of 39.3 degrees. So once again, when we are charged with solving a triangle and we don't have, we can't use the law of sines initially, we want to start using the law of cosines, and we want to use it on the largest angle that we can.